Welcome to the practical demonstration that how to do the single plane balancing of a rotor. So in this video we are going to discuss and also give you a practical demonstration and practical how to do the balancing on site. So first of all I want to apologize to you guys for delaying this video because I have to collect lot of information from site. I have to arrange some videos for this video, right? So that's why. So let's start this video. This video will be divided into four main categories. First will be like the safety and the setups, instrument setup as well as the site setup. Second will be the initial run. Then we are going to see the trial weights and trial runs, and the last we are going to see the trim and the corrections, right, if needed. So let's start with the safety. So I have mentioned here very basic points of the safety because it need to be updated based on the site conditions and the type of equipment and the area where you are performing this job. So very basic points I have covered up here, that is that we have to make sure the full PPE should be there, our clothing should not be loose, and you should be well aware where this emergency stop for that particular machine is, because and also there should be no restrictions or obstacles between you and that emergency stop. And we have to ensure that that all the people or all the personals near are clear, are away from that machine while doing this job. So let's discuss the practical setup. So in the setup, first of all we are going to put on the reflective tape. So this reflective tape will be fixed on the on the rotor shaft, or maybe the coupling, or the available the easy accessible rotor nearby to the drive-in or the non-drive-in bearing. Here in this case we have put on the sensor and the reflective tape both at the drive-in side of the sensor, drive-in side of the machine. Okay, so the reflective tape I have mounted here on the shaft in this video, right? And we have to make sure that before mounting this tape, the surface area of that particular shaft, or the location, or you can say the coupling where you are mounting this tape, it should be it should be very much clean. There should be no oil, or there should be no dirt. Otherwise, once the machine will be at nearby its full RPM, it may come out and you have to start the process from zero, and it's a waste of time and the money, and so it's a kind of a hurdle. So we have to make sure that we have to fix it very carefully. So then we are going to install the sensors. So in the sensors we are having one accelerometer, that because we are doing single plane, so we'll be using one accelerometer that we can mount in radial direction. So radial direction, it can be horizontal or it can be vertical, right? So in this video or in this demonstration, I have mounted the sensor in the horizontal direction. And the next is the tacho. So tacho also we have to point it out directly towards the reflective tape that we have installed. And both the accelerometer and tacho should be at 0 degree with each other, else let's say if you are putting this tacho at the top and at the top side, and the sensor at the horizontal side, then you have to make sure that you have been mentioning this angle difference, whatever the angle difference is there in both between accelerometer and tacho inside that analyzer or the setup. Otherwise the calculation will be wrong. But to avoid this, I will be recommending you to either use both in the horizontal, or use both in the vertical side of that particular housing or machine, right? So here I have mounted both at 0 degree, and both are in the horizontal side of the machine. Okay, and this setup will be fixed until the job is complete, so we will be not moving this setup. And then the next we are going to connect these both the sensors, that is accelerometer and tacho, to our analyzer, and we will be verifying that we are receiving the proper signal from both of them. Okay, so now we will be moving toward the setup of the analyzer. So in the analyzer, whatever type of analyzer or the brand analyzer you are using, here in the demonstration I have used the SPM, Lenovo and Emerald, but you can use anyone you want. All the analyzers are same, all are having the same features, same calculations, just there will be a little bit of difference of the screen and maybe some kind of the setup screens, there may be some difference, but otherwise it's a very basic and same kind of information you have to feed everywhere. So we have to, you have to choose the type of balancing. So here we are doing single plane, so you have to choose the single plane, and also we have to select the transducer type that we are selecting. So here we are using accelerometer, so we will be selecting accelerometer. And if you are doing the balancing of the turbine and there is any kind of displacement sensors, then you will be selecting the displacement sensor or proxy probes. But here we are using the accelerometer, right? And also it's very important to define the rotation, like what kind of numbering or what kind of, how we are going to define the angles for that particular impeller. So either we are going with the, with the rotation, the angles we are going to mark is with the rotation or against the rotation. So it's very important. So because if you will not put this information correctly, let's say you have put on the wrong information, you have feed against the rotation, and while doing the balancing you have start marking the angles in, towards the rotation, then everything will be wrong. So that's why it's very important to decide earlier and put it in the setup that which type of numbering or which type of which side that you are going to mark the angles in the impeller, right? So after doing this setup, let me show you the practical, that how the setup will look like. So here in this video, this you can see the live balancing. I have did the balancing of huge ID fan there, and you can see the reflective tape, you can see the tachometers and the sensors. I know that you can comment on the condition of the site, but it's shutdown is going on and lots of maintenance work is there, so that's why 5S is very poor. I do understand that, please don't start commenting on that. So you can see here the analyzer. So here you can see the two slots. One slot is for accelerometer and one is for tacho. The blue one is the accelerometer. So I will be putting on this accelerometer, we will be marking the red these both marking positions and insert the connector there. Another one, the black color, is dedicated to the RPM, it's towards the tacho. So here I will insert it. Sorry, it's little bit tight. Here you go. So here we insert the both of the cable. So this is the normal setup, that how you are going to do on site, right? So now let's move towards the next analyzer setup. So here you will seeing that in the analyzer setup I will be selecting the option of balancing. Here is it, and we are doing single plane. Click here, enter. Here is the transducer type. So since we are using here accelerometer, so based on which type of machine, which type of sensor you are using, you can select, and here we go. That's it. So this is the main screen you can see here. So this is the entire setup, that how you will be going to make, and we will be not moving this setup, neither the reflective tape, neither we are moving the accelerometer, neither we are moving the tachometer. Okay, so now once we have finished this, now we will be understanding that what is this rotation and anti-rotation, because most of the people do the mistakes here, because they are not aware that whether the numbering or the angles they are putting there, whether it's with rotation or it's anti-rotation. So this picture will give you a clear idea, this slide will give you a clear idea. Let's say this cartoon towards the left hand, just consider ourselves. So this is what we are looking towards the impeller, and impeller rotation is marked with the white arrow. So you can see the first one is the anti-clockwise. Some people say anti-clockwise, some say anti-rotation, some say counter-clockwise, so everything is same. So here you can see that the marking of the angles are, it's against the rotation. So normally what happened, that whenever we are doing the marking against the rotation, so what people feel that okay, they start rotating the impeller against the rotation. Let's say the impeller is moving here, let's say from top to down, so what they will do, okay, it's anti-rotation, so they start rotating the impeller towards the upside, but it's wrong. If you see here in the first image that you're seeing towards your left side, so you see that first angle is my 0, and if I will rotate the impeller in the same direction, the direction which the impeller is normally rotating, and start doing the numbering, and let's say putting on the angles, first is 0, then 45, then 90, because here there are only 8 blades, so the angle difference is 45. So you can see that I am rotating the impeller in the same direction, the direction where normally the impeller is rotating during the process, and my numbering is going the against the rotation, right? So in the same way, now you know this 0 45 that I have written, so you can also mark it like this: 0 1, 45 will be 1, 90 will be 2, 135 will be 3. So in the same way you can mark it from 0 to 7, because total 8 blades are there. Now let's say if you're in your analyzer, if you have selected for the same machine, same impeller, now you have selected the option of clockwise, that you are going to do the numbering or putting on the angles in the clockwise direction. So in this case you will be rotating the impeller against the rotation. That means now you will be rotating the impeller upside, not towards the with the rotation, that is downside, upside. So that then you will see that numbering will be automatically clockwise. That is, you can see 0 45 90. Okay, I hope this slide will give you a very clear idea, and it's very important. Please hold the video and look after this image again, and go back and listen again whatever I have said to you here. Okay, so now I will be showing you. Let's go move to the field again towards the practical. So here I have already taken the initial reading. So the initial reading is 1.97. This is the amplitude of the unbalance, and the initial heavy spot angle is 132 degree. So now we will be seeing here that how to put on the trial weight. Now I will click on the next here. Let's say edit test weight. You can put the manual. So manual, with the help of the with your experience, you can put on. Let's say here I will be putting somewhere around 350, around 340 or something like this. So you can just use your experience, and based on that you can put on your weight, because to exactly calculate the trial weight, theoretically you will be needing the rotor mass and the rotor radius, which is very difficult to get on site with the client. Okay, so but here for you, for your knowledge and information, I have taken the details from the client, and I will show you that how to calculate this by using the analyzer. All of your analyzer, all of your people are using your whatever the analyzer you are using, everybody is having this option. So here you can see the rotating mass of this impeller is 11488 kgs. So I have put it okay. So now down the radius I will calculate. Now I have taken this information of the radius with the help of the drawing here with the client. So here the radius is somewhere it's 3280, so mm. So here I have put it okay. So rpm automatically machine is having from the TECO, so the calculation is around 349 grams. So and this is what we are going to put on the trial weight. So if this details are not there, then you have to, what you have to do, you have to use your own experience to guess that what weight, or what weight we are going to use here for the balancing or the trial purpose. So this is the next video. You can see that I have put on the same trial weight. So what is the weight of this trial weight? The same that we have seen in the last video. It's somewhere around 350 grams, right? So now see, we have welded the trial weight here in the impeller, but now you can ask me that how I have calculated what is the angle that I have put on this weight, right? That is the main important question, because we have already seen that how to do the numbering and how to put on the angles, and we have, for this practical session, we have choose anti-clockwise, or you can say the anti-rotation. So in the what initial phase reading what the initial phase we got in our initial reading, that is around 132 degrees. So that is the heavy spot, right? So heavy spot. And what is this 132 degree reference? The reference taken by the instrument is from the reflective tape, right? So what this instrument is telling us, that from the reference of that particular reflective tape in the anti-clockwise, because we have choose the anti-clockwise, so in the anti-clockwise or anti-rotation, if you go towards 132 degree, that is your heavy spot. Okay, so to counter this heavy spot, what I will do, definitely I will be putting the weight opposite to that, right? So to counter this heavy spot, what I will do, I will be adding on 180 degree in this. So 132 plus 180 is somewhere around 312 degree. But now here there is one condition. What? That since we are using the readings in velocity there, I mean the amplitude we are using 1.9 mm per second, but the we are using accelerometer that is giving us the acceleration. So always there is a difference of 90 degree, between the acceleration and velocity because of the integration, right? So the actually, as per theory, it should be that we have to add 90 more so that we can have the exact angle. So if I will add 90 more, that means 132 plus 80 plus 90, so I will be getting 402. There is no 402 because 360 degree is the full circle, so it will be 42 degree, right? So since I am using the velocity, so I should mark this, put on this trial weight at 42 degree in anti-clockwise, by using the from the reference tape, right? Remember, please hear that still I have not decided my 0 degree here. I am just using reflective tape as a reference to identify my position of the trial weight. But in some case this theory is, I have, this is my practical experience, everybody can have their own experience. In some cases I have seen that in 50% cases that 180 degree is giving good results. In some cases I have seen that 400, 180 plus 180 plus 90 is giving good results. So here first in this practical session I have taken the 180 degree, and let's see that how it goes. Okay, so I believe you have understand that how we have to decide that what is the exact location that where we have to mine the trial weight by using reflective tape as a reference. Okay, so now this is the next slide will give you a full idea. So since we are going anti-rotation, so this is the white color that you have seen, you are seeing here at 0 is the reflective tape. So remember, still reflective tape is not 0 because still I didn't identify the 0, right? So this is just a reference. So reflective tape is the reference. I have tried to calculate my angle, and you have remembered that what is my angle, because I have considered 180 degrees, so angle was 312. So 312, let me somewhere nearby around the 7th blade, so that is 315 because total 8 blades are there. So I have put on this around 315 degree, and now I will mark this trial weight position as 0. So why I didn't mark the reflective tape as a 0? Because normally in such kind of big impellers, let's say that it's very hard for me to get the exact 0 because the reflective tape, let's say, is downside. So for me to go and take the exact measurement where is that exactly 0 is very hard. So that's the reason that since it's a trial that we are going to do here, it's not a final weight, so I can just roughly calculate this angle of this trial weight, and I will keep this trial weight as a 0, and this trial weight I am going to mount exactly on the blade, because I don't care, there will be slight vibration up and down because the correction weight should be perfect. So to make that correction, to calculate that correction weight perfectly, I will be putting on this trial weight at exactly parallel to that or near to that blade of that fan. Okay, so total 8 blades are there. So this red mark will be my 0, that is the trial weight. So the what was our trial weight? That was 347 grams. So I have mounted it at 0 degree. Okay, so this is my 0 now. So let's go to the practical field. Here you can see that I have put on 349 degree, and once I have put the 349 degree weight, so the trial readings, the trial run, I have get that 3.73, the vibration increased and my angle changes to 166 degrees. So let's ask the machine what is the correction weight. So correction weight is showing 290 grams at 118 degree. So 118 degree from 0, and what is my 0? My 0 was the trial weight. So that means still the angle calculation was wrong. I have to slightly go approx 100 degree above that, right? So here you can see, here if you want to change the weight or angle, then you can put on here, you can edit it, but I will here I have just put the exactly the same amount of weight, so no need to do that, right? So once we put on this weight, then we are going to do the trim here, right? So now I will what I will do, I will be calculating the the weight by using the weighing machine. So this was the weight, I believe 280, 87, this is 87, 88. This is the trial weight piece that you can see here. Okay, so this is what I am going to use as my correction mass. And if you have seen in the last video that we have choose the option to remove the trial weight. So it's up to you whether you want to keep it or you don't want to keep it. If you want to keep it, then you have to select the option that I want to keep the trial weight, but I will not recommend you that, because unnecessary, there is no need to put on lots of weight. So try to remove the trial weight always. Okay, but let's say if there is some machine which is very congested and very hard to remove any weight, then in that case you can definitely go by that okay, I don't want to remove the weight. But in this case we have removed the trial weight. So next slide will give you more clear information. So here you can see that we have removed this weight that is marked with the red, remember here, and now you can see that I have changed the angles. So 0 is was my trial weight, right? And what was my correction weight? My correction weight was 290 grams at 118 degrees. So from this 0 I have to go towards the anti-clockwise. Okay, anti-clockwise, and I have seen that check that where is my 118, somewhere between those blades. That means 90 to 135 degrees, somewhere here, that I have marked here as a green. So what I will do, I will remove this 347 gram weight and I will be putting here clockwise 290 gram weight. Okay, so this is what I will be doing here, and I will be putting on this 290 gram weight. Now let's move to the practically on field. Okay, I will show you here. Okay, I have removed my trial weight, I have put on my correction weight, and here is the trim reading that we are going to take now. Okay, so this is the live reading that you can see here. So RPM is stabilized at around 948 degrees, and you can see that slowly the machine is preparing, it's settling down, and it's start measuring the vibration. So you can see here at the top that the overall the vibration is somewhere around 0.656, okay, mm per second. But here you can see that this is not the 1x, it's a full spectrum. So it's a complete overall vibration of that particular drive inside bearing. Okay, so what is the overall vibration? The overall vibration of this bearing is 0.656 mm. So this is what 1x is. 1x is only 0.29, and this is the trim balancing weight that is showing, but I don't think so there is any need for this. But you can just make a note, it's 43 grams. Okay, just take a note, because I will be telling you that how to do trim if needed, but here there is no need because it's already 0.29. So 43 grams and angle is 246. Okay, so this is what we are going to use, and I will be showing you that if let's say that the vibration is not up to accepted level, then what you are going to do in that case. So finally our balancing is almost complete here, right? So this is the picture that will define you very clearly. Okay, so this red one was our initial trial weight, the green one was our counter, that is the correction weight, that is 290 grams. Okay, and this yellow one that I have shown you is the trim weight. That means that let's say that after putting the weight of 290 grams, let's say our vibration is not up to the acceptance level. In that case you can go with the trim run, and if you will go with the trim run, I think if you remember I told you that that machine was showing 43 grams at 246. So in this case now 0 is already fixed, that was my trial weight. So you can see this location of 246 it here. If by chance my vibration is not up to my acceptance level, so what I will do, I will put on 43 grams here, and then again we'll take the reading and vibration will drop down further. But in this case there is no need, because already vibration is within the limit. So okay, so yes, so this is the next slide, that if vibration within the acceptable level, then job done. Document the final readings and just make the report. But let's say if not reduced, then you know what to do. We have to keep the correction weight there only, and we have to go for the trim. Okay, and this is how you will be going to do further if let's say the vibration is not reduced up to that particular acceptance level, and let's say that vibration did not reduce at all and it's behaving unusually. That means we have to remove our correction weights, all the weights, and we have to check that whether we did the proper setting or not, tachometer and everything is perfect or not. And if everything is perfect, then definitely you have to see that maybe the machine is having some other issues, not accept unbalance. That's the reason that why we always recommend to do the vibration analysis before taking any corrective actions like balancing or alignment. Okay, so thank you guys. I hope that you have learned that how to do the balancing, but it's a quiz time now. So the first question will be that what does 0 degree represents on the rotor during balancing? Four options are given here. Mark your answers like Q1, whatever your answer option is. Then the Q2 is, let's say that your trial run shows 15-degree change in the vibration compared to the initial run. Then what action you are going to take? Again, just select options among the four. And the third one is, let's say that after the correction weight run, or you can say the trim weight run, the vibration reduced but not up to that acceptance level, and you choose to keep the correction weight for the trim. That means you are moving towards the trim. So what does the analyzer will do in that case? So again, the four options are there with you. And the last and the important question, you will tell me that diagram 1 and diagram 2 both, okay, which one is marking is anti-clockwise and which one is clockwise, or which one is against the rotation and which one is the rotation. Please note that don't copy the same thing that I have explained you in this video before, because I have changed the direction of the impeller. Okay, this side is moving, impeller is moving from down to upside. Okay, so I will be waiting for your answers in the comment section. Thank you guys for being with us. Thank you for watching, and I hope this will will be very helpful and make you guys very much comfortable for doing single plane balancing anywhere with any type of rotor. Thank you very much. Please subscribe to the Skill Talk for further such videos, and I hope that you like this video. Please hit the like if you want to see more such videos. Okay, thank you very much. We'll meet you in the next video. Till then, put on your comments with all of your answers. Okay, thank you. Bye. Take care.